everyone. Yesterday we discussed about vector atoms model and today we learn about LS coupling. Without wasting any time, let's begin.
LS and JJ coupling, a general Hamiltonian for an atom looks something like this. The first term is due to the central field approximation. The second term is due to the residual electric field not taken care of in the current central field approximation. The third is due to the interaction between the spin of the electron and their orbital motion. The last term is due to everything else. We will neglect this LS coupling. In LS coupling we assume that the residual part of the Hamiltonian is much larger than the spin orbit part, in which case our Hamiltonian becomes this. The spin orbit part may be added later as a small perturbations. This Hamiltonian commutes. The orbital and spin angular momentum operates as well. Their zero component. In this case of LS coupling, we can find orbital angular momentum by summing the orbital angular momentum of the individual electron, and likewise with the spin angular momentum. The total angular momentum is the sum of this JJ coupling. In JJ coupling, we assume that the residual part of the Hamiltonian is much smaller than the spin orbit part, in which case our Hamiltonian because this which commutes with the individual total angular momentum of the electron and their Z component. In this case, it is only worth defining the total angular momentum, which is given by the sum of the individual angular momentum of the electrons. Applicability: LS coupling is more applicable with the light nuclei. JJ coupling is more applicable with heavy nuclei.